Hi, here is Devendran from Yuva Maha Academy. We are going to solve chapter wise important questions in each video. So I am going to upload important questions in each chapter. So please subscribe and share the videos. In this video we are going to see 5 more important questions in the polynomial chapter. Already we have solved 10 important questions in the previous 2 videos. Let us see one by one. This is the first question. If the product of zeros of polynomial ax square minus 6x minus 6 is 4, find the value of a. So to find the value of a, we can use the relation between the coefficients and the zeros. If ax square minus bx plus c is a polynomial with the zeros alpha and beta, we can write the relationship between the product of zeros and the coefficients like this: alpha into beta is equal to c by a. So here a, b, c are nothing but a is the coefficient of x square, b is coefficient of x, and c is the constant term, and alpha and beta are zeros of the polynomial. Here it is given the product of zeros of the polynomial is 4. So 4 is equal to, here what is c and a? C is minus 6 and a is the a itself. So c is minus 6, constant term, and then a is a as it is. Now multiply 4a is equal to minus 6, a is equal to minus 6 by 4. So we get a is equal to minus 3 by 2. So this is the value of a for this given question. Let us move to next question. So the next question, find the quadratic polynomial, the sum of whose zeros is 8 and their product is 12. Hence find zeros of the polynomial. So here we have two parts in the solution. First I have to make a quadratic polynomial for the given values, and then I have to find the zeros of the obtained polynomial. Let us find the first part. The general expression for a quadratic polynomial we can write So this is the general expression for a quadratic polynomial, where alpha plus beta is the sum of zeros, alpha into beta is the product of zeros. Here sum of zeros given 8 and the product of zeros is given 12. So straight away we can substitute in the general expression. Now the required polynomial, therefore x square minus alpha plus beta is given 8. So minus 8x alpha into beta, product of zeros 12. So plus 12. So this is the required quadratic polynomial. So this is the first part in the solution. The second part, I have to find the zeros of the polynomial. To find the zeros of the polynomial, I have to equate the given polynomial to 0. To find the zeros, x square minus 8x plus 12 is equal to 0. Now we have to factorize the polynomial and then you have to equate each factor to 0 to find the zeros. So here middle term is minus 8 and then coefficient of x square is 1. So product of 1 and the constant term 12, 1 into 12, 12. I have to split this 12 so that the product is 12 and the sum is minus 8. So factors of 12 are 2 and 6. So we can write 2 into 6 is 12 and then sum should be minus 8. So we can put a negative sign to both the numbers. Minus 2 minus 6 is minus 8. Minus 2 into minus 6 is plus 12. So we can write this x square minus 2x minus 6x plus 12 is equal to 0. After that, taking common factor, x is common here, remaining is x minus 2. Here minus 6 is common, remaining is x, and then here minus 6 into minus 2 is plus 12. So minus 2 remain here is equal to 0. Now x minus 2 is common. Taking x minus 2 outside, remaining is x minus 6 is equal to 0. Equating separately to both of them, x minus 2 is equal to 0. Therefore, x is equal to 2. And then x minus 6 is equal to 0. Therefore, x is equal to 6. Therefore, the answer is the zeros of the polynomial is 2 and 6. So, let us move to next. This is the third question. If one zero of a polynomial a square plus 9 into x square plus 13x plus 6a is a reciprocal of the other, find the value of a. We know the general polynomial expression ax square plus bx plus c. In this, if the zeros are alpha and beta, if alpha and beta are zeros of this polynomial, then alpha and beta product of zeros is equal to c by a. So here a is nothing but coefficient of x square and c is the constant term. So similar, in the given polynomial, a is a square plus 9 and c is 6a, and beta is, according to question, 1 0 is a reciprocal of the other. Therefore beta is equal to 1 by alpha. We are substituting them in the previous equation. Alpha into, instead of beta, 1 by alpha is equal to 6a by a square plus 9. 6a is nothing but c, and then a is a square plus 9. Now cancelling alpha and alpha, we get 1. 1 is equal to 6a by a square plus 9. Taking to the right hand side, a square plus 9 is equal to 6a. Now taking 6a this side, it becomes minus 6a. Now I have to split the middle term. Here coefficient of a square is 1. So 1 into 9, 9. I have to get the sum as minus 6. So minus 3 into minus 3 only, plus 9, and the sum is minus 6. So we can write this minus 6a as minus 3a minus 3a. Now taking common term from the first two. A is common, remaining is a minus 3. Here minus 3 is common, remaining is a minus 3 into minus 3 only, plus 9. So minus 3 here is equal to 0. Now taking a minus 3 common, a minus 3, and then again a, here minus 3. So a minus 3 into a minus 3 is equal to 0. If we equate separately to 0, we will get a is equal to 3. So value of a is equal to 3 for this given question. Let us move to next question. This is the next question. Find the quadratic polynomial whose zeros are 1 and minus 3. We know the general expression for a quadratic polynomial. If alpha and beta are zeros of a quadratic polynomial, then the polynomial is written as x square minus of alpha plus beta plus alpha into beta, where alpha and beta are zeros of the polynomial. Here the given zeros are 1 and minus 3. Here alpha is equal to 1 and beta is equal to minus 3. Therefore, the required polynomial is x square minus alpha plus beta. Alpha is 1, beta is minus 3. x plus alpha into beta. Alpha 1, beta is minus 3. Simplifying this, we get x square 1 minus 3 is minus 2, minus 2 into minus plus 2. So 2x, here 1 into minus 3, minus into plus minus. So we get minus 3. So this is the required polynomial. Let us move to next question. This is the next question. Find the zeros of polynomial 5x square minus 4 minus 8x and verify the relationship between its zeros and coefficients. Its solution contains two parts. First we have to find the zeros of polynomial and then we have to verify the relationship. To find the zeros of polynomial, we have to equate the polynomial to 0. By splitting middle term, we have to factorize and then each factor should be equated to 0 to find its zeros. Here middle term is minus 8 and then the product 5 into minus 4 minus 20. I have to split this minus 20 to get this sum minus 8. So we can consider the factors of 20 as 2 and 10. If we put a minus sign to the minus 10, we will get this sum as minus 8. So we can write this as 5x square plus 2x minus 10x minus 4 is equal to 0. We can rearrange this equation as 5x square minus 10x plus 2x minus 4 is equal to 0. Now taking common factor from 5x square and minus 10x, we get 5x is the common, remaining is x, and then here 2 into 5, 10. So we can put 2 here, x minus 2, and then here 2 is common, remaining is x minus 2 is equal to 0. Now taking x minus 2 common, remaining is 5x plus 2 is equal to 0. Then equating separately to 0, we get x is equal to 2, and here 5x plus 2 is equal to 0. Therefore we get x is equal to minus 2 by 5. So the zeros are 2 and minus 2 by 5. Now we have to verify the relationship between zeros and the coefficients. Coefficients are nothing but x square coefficient 5 and then x coefficient minus 8 and constant term minus 4. We have two relationship between zeros and coefficients. Alpha plus beta is equal to minus b by a. Here a is coefficient of x square 5, b is coefficient of x minus 8, and c is the constant term, that is minus 4, and alpha value is one of the 0, 2, and beta value the other 0, minus 2 by 5. Now we can substitute this in the first relation, alpha plus beta. 2 minus 2 by 5 is equal to minus b, minus of minus 8 divided by a, 5. Now if you simplify this, here LCM is 5. So 5 into 1, 5. So 5 into 2, 10. 10 minus 2 is equal to minus of minus plus 8 by 5. After simplification we get 8 by 5 here, here also 8 by 5. So the first relation is verified. The one more relation, product of zeros, alpha into beta is equal to c by a. Here alpha and beta value 2 and minus 2 by 5 is equal to c by a. C value minus 4, a is 5. Now 2 into minus 2 minus 4 divided by 5 is equal to minus 4 by 5. So both the sides are equal, therefore relations are verified. So like this, we have to find the zeros of polynomial by middle term splitting method. Then I have to verify the relationship substituting the given coefficients and the zeros. We will see in the next video some other chapter with important questions. Those are asked in the previous board exams. Thank you.